Hello everyone. So not long after I posted the video on the EG-01 function generator, did someone comment and send me the manual. And here she is. EG-01 instruction manual. Super cool. It's about 7 pages. Here's the spec sheet. So yeah, 100 to 100,000 hertz. 3 outputs. 60 volt peak to peak, 5.6 RMS, about 3 pounds. And also, coolest of all, came with a schematic. So if you look here, 1988. I was redacted years old in 88. Actually, September 14th. Oh, September 26th. That's almost my birthday. How about that? But anyway, if you look at this, pretty cool. You got your input power. I like the double throw there on the power, break both lines. Transformer, rectifier, here's our light on the front. Here's our amplifier chip, LM380. Here's our function generator on a chip, XR-2206, so you can look that up, which I did, and I'll show you. All kinds of inputs connected to that, of course. So if we look at the spec sheet for that, XR-2206, I don't know why this focus is breathing so much. Let's go manual and just set it and forget it. Other way. There we go. Triangle wave generation. So right there, simply by open circuiting pin 13 and 14. So if you want a triangle wave, let's just zoom out here. Right there. There's their switch on the front. Sine / triangle. Pins 13 and 14. So one or the other. And it says the amplitude of the triangle wave is approximately twice that of the sine wave, which we saw in the last video. Kind of cool. And then what else we got here? There is our time constant equation. So F equals 1 over RC hertz. So you can adjust C or you can adjust R to change your frequency. And in this calibration, they use trim pots, so they adjust the R's. So on this here, let's see here. There we go, a little better. Here's our C's, and then here's our R's. So they adjust these R's on then pin 7 right there. And here's all our trim pots. So we're adjusting the R in that equation to change the F. Kind of cool. Yeah. It also says in the manual, or actually in this kind of a funny note here, it says LM380, let me get some light on that, has a Staver V7-2 heatsink. So that's like a kind of a clip thing that goes on your, pulls the heat away from the chip. Now ours does not have that. Let me look at this here. There's our LM380. Power's on, and I'm just jamming my finger in here. That's probably not smart. There's no heatsink on it. Now I don't think it gets terribly hot. I can touch it. It's not room temperature, but it's barely warm. But it's curious. They said it has one, so I don't know if it had one and someone took it off or never did have one. But anyway, let's try to adjust this a little bit. I'll try to get the whole dang thing in the frame. Let's see, continuous. Let's pull this up. Drop this down. Give me a second here. And let's go back. There we go. So top right is my frequency counter. Now it says to start on the 10,000 on the high. I did play this a little, so it's already kind of dialed in. But that should be 100K. And I'm at about 100K, so that's pretty good. And if I go here, it should be 10K. And that's close. Pretty good. So we got 1,000. The low on or the high on the 100. Excuse me. This is 1 to 10,000 now on the range. So the high should be 10,000. I'm at 10-ish. Pretty good. The low should be 1. I'm at 0.1 ish. I did try to tweak this down some more. This is the mid on the low, and I think I reached the limit of this pot. I don't think I can go any lower. I can only go higher. It would help if I was actually in the pot. There we go. Yeah, I can bring it up, but I cannot go down. That's as low as I can go. That's fine. This one's a little trickier. So this is 100 to 1000. So this should be 1000. It's almost, right? So if I go the high and the low, let's see. I can tweak that up a little bit and try to dial it in. Ooh. Pretty close. Pretty close. And if I go back to the low, this should be 100 hertz. And I'm at almost 0.09, almost at 0.1. So that's pretty cool. I can't believe. Andrew, you are a scholar and a gentleman. I can't believe you had this. So anyway, hopefully it's a short video. Super cool. Again, thank you, Andrew Allman, for sending this to me. I will keep it in my collection. And again, I'm willing to share this with whomever. I just can't link it, apparently. I can't link outside YouTube because I'm a new user and I'm not popular enough, which I've been saying that since high school. But yeah, schematic, 1988, super cool. So I will button this up, call it good. Maybe I'll give it away or sell it. I don't know. Anyway, thank you for watching. Like it if you liked it. Subscribe if you like this kind of stuff. And I'll see you soon.